Today we're going to graph and analyze radical functions again. The other day we talked about how to graph them, and we talked about the domain and range and the transformations of radical functions. Today we're going to go over what's the end behavior zeros, intervals of increasing and of decreasing of radical functions. But before we do that, I want to review a little bit what we did in 7.3. So I want to talk first about these parent functions. So the parent function of a square root is f of x equals the square root of x, right? And this looks like, if we were to graph this, it looks like this, and it goes up to the right, okay? Then we're going to talk about also the cube root functions. These are what we call our parent functions again. So this would be f of x is equal to the cube root of x. And if I was to graph this, it looks pretty much like this. So that is the basic cube root function, okay? So the other day, when we talked about the transformations to the Kercher graph, we said y is equal to a, and then we take a root, could be a square root or a cube root. We do 1 over b, and then x minus h underneath the radical, and then plus k. So if you recall, we said if a is negative, so if I were to put this negative out in front of here, that means it would be a reflection over the x-axis. And then our a, just our a in and of itself, a is going to be a vertical stretch or compression. Okay, and that depends on whether if a is greater than 1, then it's a vertical stretch. If a is less than 1, meaning if it's a fraction, then it would be a compression. And then if this was negative here, so if b was negative, then we would say that it's a reflection over the y-axis. And then our b, if you recall, that's this b right here. So b tells us it's a horizontal, again, stretch or compression. And the key with this one, guys, is it's going to be opposite. So it's going to be the 1 over b, which means if it was 1 over 4, it would be 4. It would be a stretch by 4. And if it was 4, it would be 1/4. So you're always going to invert it, okay? Or you're going to, let me go ahead and get a little more page here, okay? Then we're going to talk about let's see if I can do black here. So the h, and remember h means what? We're moving right or left. And we said when it's a plus there, we're moving left, right? And when it's a minus, we're moving right, okay? And then our last one has to do with this k, and our k means we're moving up or down, okay? And up is positive, and down is negative. Whoops. There, okay? So now we're going to jump right into the next page. So that was a review of what we'd already learned, and so here again, we're going to talk about what this question is asking us. This question is asking us to graph and describe the transformations, then find the domain and range and behavior, zeros, and the intervals of increase and decrease. So again, I always want to talk about what our parent graph is. So our parent graph is f of x is equal to the square root of x. Now that's important because now we can see what are the transformations, right? So do y'all notice this negative out in front of here? So that negative is going to cause our graph to reflect over what? The x-axis, because it's a. So this is a reflection over the x-axis. Then let's talk about this plus 5, which really means it's moving minus 5, because if you recall in the equation, it's x minus h, right? So this is going to be left 5. Now here again, I'm going to show you guys down here. This is what our square root graph looks like, right? So this is telling us that our graph is moving left. So that means it's going to go 1, 2, 3, 4, 5 to the left, okay? So that means our graph is going to start over here. Now the other thing it says is it's a reflection over the x-axis. So if it's a reflection over the x-axis, it's going to go down, right? So our graph is going to look something like this, okay? It's going to go down and across like that. So that's what we know. So what I want to show you guys now is how to use the table function on your calculators for you to basically fill in this table and figure out what the graph looks like. So once again, if you guys have a TI 83 or 84, you can go to y is equal to here, and we can go ahead and put this in here. So we're going to use our negative symbol down here, and then the square root here of x plus 5, okay? Now we can go ahead and graph this right here, second graph, and we can see, whoops, sorry, I should just click graph. Sorry about that. And it's showing us our graph. And indeed, it is looking the way that I said it would look, right? So it is reflecting off to the bottom and the right because it reflected over the x-axis, okay? So now we can use our table function. And so we're going to go second table here. And the way this is set up right now is it's starting at -5 and it's going up to 5. And let's go here so you guys can see how we can change this. So this is how we set up our table. Go second window here. That's our table set. Okay, so our table started at -5. We can change that number to be -10 if we want to. And right now it's on auto. But we can also change it to ask so we can put in our x values. So let's just go ahead and see what this looks like for right now though. So we go second graph here with this one. Notice now that all of these numbers, -10, 9, 8, 7, 6, those are all errors. And that's because when I put those values in there, I get a negative underneath the radical. So our value actually starts at -5, right? So now I want you guys to notice an easy way to pull some numbers here from this table is to look at where we get whole numbers. So at -5 we get 0. At -4 we get -1. At -1 we get -2. Now if we want to eliminate these numbers here, then we're going to go back here to second window and we're going to actually change this number up here to -5. So now when we look at our table, it's actually going to start at -5. So now we have one more value, that 4, -3 that pops up, this whole numbers. So those could be the numbers that we pull and put into our table. So that's what I'm going to do. So I got -5, 0, and then I had that -1, -2, and then I had 4, -3. Now these are enough for me to at least get a visual graph. So at -5, 0, that's right there. And then we got -1, -2, that's right there. And then we've got 4, -3, okay? So this is enough for us to get our graph, at least a good representation of it, okay? Now we're going to talk through the rest of this. So if you recall, we already talked about domain and range, and we talked about those the other day when we did 7.3. So domain it has to do with our x values. Hopefully y'all remember that. So when we're talking about our x values, what's happening to our domain? So our domain is getting bigger, right? Because the graph is moving to the right. So this is going to be greater than or equal to. And what number is it greater than or equal to? It's the h, which was this number right here. And if you recall, with this number right here, it's actually a -5, right? And that's the value that we started our graph with. Now our range is going to be our y values. What's happening to y? Is it getting bigger or smaller? Looks to me like it's getting smaller. And where did it start? It started again at 0. Did y'all notice that right there? That y value for that is 0. Now when we talk about end behaviors, we're talking about as we move on the x-axis, what's happening to the y values. So remember, this is equivalent to y right here. Okay, so as we go to the right here on this graph with our x values, what's happening to our y values? Do you notice they're moving down? So that means this is -infinity, right? Now let's talk about what happens when we move left. So now when we move left, what's happening to our y values? They're going up, but they end at 0. Do y'all notice that? So that's what's happening with our y values when we're talking about end behaviors. Now, when we talk about zeros, what we're talking about is setting the equation that we have equal to 0 because we want to find the x-intercepts. So when we do that, we're going to say 0 is equal to negative square root of x plus 5. So we would multiply both sides of this times negative 1 so that we can get rid of that. So we end up with 0 here. And then that's going to be the square root of x plus 5. Recall that the way we get rid of a square root is to square it on both sides. So that's going to be 0 is equal to x plus 5. Then we're going to subtract 5 from both sides. So that means x is equal to negative 5. So that is the 0 of my function. And indeed it is. Notice right here, again, that is where the 0 of our function is. That's where the function crosses the x-axis. Now, when we talk about intervals of increasing and decreasing, these have to do with our x's. So as we move on the graph from left to right, so now as we move on this graph, so I'm going to actually get the graph here and I'm going to the right. Let me do it in black. No, actually I'll do it in blue, a different color. So we started here and we're going this way, right? So is the graph rising or falling, y'all? Is it increasing or decreasing? Yes, it's decreasing. So that means our interval for increasing is none. And so when we're talking about decreasing, so what are the x values? What's happening with the x values? So the x values are, and when it's a number, y'all, we're going to put a bracket over here. So this is going to be, it starts at negative 5, right? Isn't that where the graph starts? And then it goes on to infinity, doesn't it? We're going to do a parenthesis there. So when we have a number, a starting point for the graph, we're going to do a bracket. And when we have an infinity, we're going to do a parenthesis. So that's our interval where the graph is decreasing from negative 5 to infinity. Okay, so now the next problem we're going to do, number 2, this is f of x is equal to the cube root of 4x minus 12 minus 1. So on this one, again, we want to know our parent graph is f of x is equal to the cube root of x, okay? So I'm going to scroll down here a little bit. So now I want to point something out to y'all. Whenever we have something underneath this radical and it can be factored, we want to do that, okay? And it's going to become important as we work this problem, and I'm going to show you why, okay? So hopefully you guys can see, like I see, that there's a 4 that's a factor of both those numbers right there. So I'm going to factor out that 4 first, and that's going to give me x minus 3 minus 1. Now here's the deal. If I don't do that, then the answer that I get is going to be wrong. And the reason for that is because the 4 can be factored out, and that 4 is going to be our b. So here we go. We're going to talk about our transformations now. So I notice that there is no a out front here, but there is a b here. And if you recall, when we have a b, that represents, so I'm going to underline that, that represents a horizontal, and I'm going to write it here, horizontal. In this case, because it's a whole number, it's going to be a compression. Because remember, this is opposite of what we would expect. And it's going to be a horizontal compression by 1/4. Now, why do I say that? Because if you recall, in the equation, it was 1 over b, right? So whatever's there, we're always going to do the inverse of it. So the inverse of 4 is 1/4. So that's why it's a horizontal compression of 4. Now let's talk about this right here. So now we have that minus 3, and that tells us that it's moving what? Right by 3, because that's our h. And then we have this minus 1 here, and that's going to mean it's moving down by 1. Okay, so that's our transformation that happened with this graph. All right, so now I want to again remind you guys down here that the parent graph looks something like this. Do y'all remember that? Okay, so when we're talking about the parent graph of the cube root of x, that's what the parent graph looks like. So now we're going to do what we did before. We're going to go to the TI-84, and we're going to look at this table. Now, one of the great things about having a TI-83 or 84 is that we can then use this to to basically find the values that go in our table, as well as to graph it. Okay, so this equation was the cube root. So if you recall, the way we do that here is we're going to do, sorry, the 4x minus 12 in here, 4x minus 12, and we're going to take that to the 1/3 power. So that's the way I do this. Remember, cube root and 1/3 power are the same thing. Okay, then we're going to subtract the 1 from it. Okay, now what I want to do is go ahead and graph this and look at it so I can get a visual representation of what this thing is going to look like. Okay, so now on our original graph, we had this transition point right here. Now I want you guys to notice that if I move this transition point 3 to the right and 1 down, that's where the graph curves. Y'all see that? And that was our H and K. 3 to the right and 1 down, right? Isn't that what they represented? Okay, so now once again, we're going to do our table function. So we're going to go second and graph. And this time it started at -5. I don't really like that. I want to go ahead and make it -10. So again, you guys can put whatever values you want in this table. If we go here to second window and we set the table, so we do that, I'm going to go down here and I'm going to put in what I want. So I'm going to click over here to ask and push enter. So now when I go to my table function, I can put whatever values I want in here. So let's say I want to put -10. See, it computes the value for me. And then if I want to do -5, which is, you know, in the middle somewhere, I can do that. And then let's say I want to put 0. Now I can also, again, I could go here, second window to table set, and I could set this to -10, and I could have it go ahead and build the table for me. If I don't know what values to put in here or what values I want. So once again, I can choose enter here, and then I can go to the table function here, and then I can just start looking for some whole numbers. Well, I don't have any whole numbers here from -10 to -1. You notice that? So I would just pick some of these. Like I'd probably pick -10 and -5. Now if I wanted some more values, I would then go to 0. Again, go to second window here, and down to, so this time I would just change this to 0. Okay, and then go again to my table. Sorry, pushed the wrong button. To my table. So now I have from 0 to 10. So I do have 0 and that's -3.3, and then 1 at -3, and then I've got, notice here, 3 -1. That's where my transition point was, and then 5, 1. And then I could also do like 10 and 2. So I'm going to take these values and I'm going to go ahead and put them in my table over here. So that's what I'm going to do next. So I'm going to take some of these values that we got. So when we did -10, we got -4.7. When we had -5, we got -4.2. And 0 was -3.3. And then we had some whole number ones. We had 1, -3. We had 3, -1. And then we had 5, 1. And 10 was at 10, 2.04, something like that. So we're just going to say it's 2. So now we're going to go ahead and plot these points. -10, -4.7. Let's just say it's about there. And then we've got -5, 4.2, maybe right there, sorry. And then we've got 0, 3.3, -3.3. And at 1, it was at -3. And then at 3, it was -1, 5, 1, and then 10, 2. Okay. So now I want you guys to notice something. Again, these values right here are going to move this center that's right there over 1, 2, 3, and down 1, right? So that's what this point right here is. Y'all notice that point? That's our transition point for our graph. So now I'm going to go ahead and draw this through these points to the best of my ability. And that's about what my graph would look like, okay? So now we're going to talk through the rest of this information. So domain has to do with x values, right? In range with y values. So this time, I don't see any limitations on our domain or our range. So when we're talking about our domain, we're talking about all real numbers, and our range, all real numbers. So here again, we're going to talk about end behaviors. So as we move this way with our graph, what's happening to our y values? Looks to me like they're going up, aren't they, guys? So this is going to be positive infinity. And then when we move the opposite direction, so this time when we move towards negative infinity with our x's, this way, what do you guys notice is happening with our y values? Yep, they're moving towards negative infinity. Okay, so here again, when we talk about our zeros, that's the next thing on this graph is our zeros. So when we talk about our zeros, that's this place over here, that's this. Whoops, I didn't mean to do that. Sorry, y'all. There's my... Oops, not doing a very good job here, but y'all get my drift. So the 0 is where the graph crossed the x-axis. Y'all see that right there? So now we want to figure out what that is. So we're going to do that by setting our equation equal to 0 like we did before. Okay, so I'm going to do that down here. So I'm going to set our equation 0 is equal to, and we've got the cube root of 4x minus 12 minus 1. So I'm going to add 1 to both sides. So it's going to be 1 is equal to the cube root of 4x minus 12. So now what I'm going to do with that is I'm going to cube both sides, right? So that's how I get rid of a cube root, is to cube both sides. So that gives me 1 here, and that's equal to now the 4x minus 12. So I'm going to add 12 to both sides. That's going to give me 13 is equal to 4x. So then what am I going to do? I'm going to divide both sides by 4. So our x, which is going to be our point where the graph crosses the x-axis, is going to be 3.25. So that is our 0. X equals 3.25. Okay? So now we're going to talk about those intervals again. Okay? So when we're talking about intervals, again, remember, we're talking about what is happening with this graph. So as I move from left to right, here's our graph. What is happening? Is the graph rising or is it falling? So I notice that the graph is increasing. So that means we have none for decreasing here. So there's not going to be any decreasing. And where is it increasing from? So isn't it increasing from negative infinity for the x values all the way to infinity? It is. So remember, when we're talking about intervals of increase and decrease, we're talking about what's happening with the graph. Is it increasing or decreasing, and from what x values? From the negative infinity to positive infinity, our graph is increasing, isn't it? All right. So I'd like you guys to attempt this problem and then come back to me. Pause the video, come back to me when you're done. Okay, so now what I'm going to do is I'm going to show you guys what you should have done with this first. So the first thing we should have done is factored out a -1 here, which would have given us x plus 4 there, and then plus 2. So now we're going to talk about our transformations again. So let's just talk about this 3 first. So that 3 means what? It's a vertical stretch by a factor of what? 3, right? Now let's talk about this -1. What does that mean is happening? So that means there's a reflection over the y-axis, right? Now, what about this plus 4 here? Which, mind you, that's really a -4 because the equation is x minus h. So this is going to be 4 left, isn't it? And then what do we have left over here? Let's see. We have this plus 2. And what does that mean? That means we're moving what? Up by 2. Okay? So here again, we're talking about a square root graph, right, guys? So that's our parent graph right there. This is saying we're moving this graph 1, 2, 3, 4 to the left and then up 2. Okay? Now it also says there's a reflection over the y-axis. So that means my graph should look something like this, guys. The beginning point of my graph is going to move 4 left and 2 up. So that's going to mean that it's going to be over here, right there. That's going to be the beginning point of my graph. So that's going to be -4. And if we plug that -4 into here, again, we're going to get 2. Okay? So you can go ahead and try it, plug it in there, or you can use, again, your graphing calculator to compute your values. So here again, if we plug in some values, we can put -4 in there. We could put, hang on one second, let me put this over. So once again, I'm going to put this in this graphing calculator, and so our equation is going to be 3. And we're going to put the square root of minus x minus 4. Notice I used the negative symbol, y'all, when I did the minus in front of the x. And then I'm going to use this to get outside of there and do the +2. So I'm going to go ahead and look at my graph first just to see if what I thought was true, and it is. And then we're going to look at our table. So here we're going to go second table set. I'm going to go here first. And this time I'm going to start with -10. And I'm going to go ahead and just have it show me the table from -10. So notice we got -10, 9.3, we've got -8, 8, we've got -5, 5, and -4, 2. So once again, you guys can see that this is a really easy way for us to get some really nice values in here, right? So I'm going to start with the -4 and 2, and then I'm going to do the -5, 5. And then, what was the next one? The -8, 8. And then I'm just going to end with that 10, 9.3. Okay? So let's go back to our table. Okay, so we're going to go ahead and fill in these values then. So then I said we started with -4, then we're going to go -5, and that other value was 5. And then we had -8, 8, and we had -10, 9.3. Okay, so those are the values we're going to plot. So at -5, we've got 5 right there, and then -8, 8 up here, and then at 10, we had 9.3. So we'll say it's like about there. So this is our graph. Okay. And notice again, it's a stretch. It is definitely bigger than the other one was, and it also reflected over the y-axis, right? So let's talk about our domain now. Okay, remember, x is going to be, and we're going to do it in the direction it's going, it's getting smaller, right? So that's less than or equal to, and again, we're going to use our h here, so this is going to be -4. Our y, it's getting bigger, so we're going to say it's greater than or equal to, and it's going to be our k. Remember that? We talked about that last week. Okay, so now let's talk about end behavior again. So as we approach, as the graph goes this direction towards positive infinity, what is y approaching? It's approaching 2. Do y'all notice that? Now, as we look at the graph and we move the other direction, we move this direction towards negative infinity, what's happening to y? It's moving towards infinity, okay? It's moving up, okay? So that's what we're talking about there. Now, let's talk about our zeros. So this time again, we're going to set, well, wait a minute. Let's talk about our zeros. Yeah, so when we look at this graph, is this graph going to have any zeros, y'all? Is it ever going to intersect the x-axis? The answer to that is no. So this is going to have no zeros. So this is going to have none here. Now, let's talk about our intervals of increase and decrease. So as we're moving from left to right, okay, is the graph increasing or decreasing? I would agree, it's decreasing. So it would have no intervals of increase, it's decreasing. And where's it decreasing from? It's decreasing from negative infinity to what point, y'all? To the -4. Again, remember, we're talking about the x values here when we're talking about intervals, okay? So here's our last example. I want you guys to tell me what's going on with the transformations, the domain, range, and behavior zeros. Go ahead, graph it, do all of that, okay? And then come back to me when you're done. All right, so on this one, so this negative out front here, y'all, that negative tells us it's going to be a reflection over the x-axis. The 2 right here is going to tell us that it's what? It's a vertical stretch by 2. Then what about this? Whoops. What about this right here? Whoa, I don't know why it keeps doing that. Okay, not trying to select it, y'all. I'm just trying to talk about this -2 right here. Okay, so what about that -2, guys? It means it's moving what? Right. 2. And then what about that -3 right there? That means it's moving down 3, right? Y'all remember that? Okay, so here again, we're talking about our graph. Our original graph looks like this, right? This is the cube root graph, okay? So when we're talking about what this is going to look like, we're going to actually put in our table the values, like -10. Again, we could, let me go back and let's go ahead and put this in that graphing calculator again and see what we get. Okay, so let's do -2, and then we're going to put in parentheses our x minus 2. We're going to close the parentheses, take that to the 1/3 power. And then we're going to click back out here, and we're going to subtract the 3. Okay, so let's graph this thing and let's see what it looks like. So yes, it looks like a reflection, doesn't it? Because the other one started low and it ended high. This one starts high and ends low, okay? So now, again, we're going to go here to second table. And maybe, let's move them really slow, y'all. I don't know what it's doing. So, second graph. There we go. So at -10, we've got 1.6. Then we got -6, 1. Notice that's a good number there. Let's go ahead and change this and move it forward so that we can see from 0. So I'm going to go ahead and change that number to 0 right here so we can see what other numbers we have. So we're going to go back in here to our table. Ooh, now we have some really good numbers. We have 1, -1, 2, -3, 3, -5, and then at 10, -7. So do y'all see those nice little numbers there that would make it easy for us to go ahead and graph this? Okay, so I'm going to pull some of those whole number values, so it's going to make it a little easier on me to graph. So we're going to go back to here. Okay. So we did have, at -10, had -1.6, or 1.6, sorry. And then at -6, we had 1. And then at 1, we had -1. 2, we had -3. At 3, we had -5. And then at 10, we had -7. Okay? So let's go ahead and plot these points now. So we've got -10, 1.6. So that's, say it's about there. And then at -6, we had 1. At 1, we had -1 right there. And remember, this should be our transition point right here. 2, 3, right? So when we get to 2, 3, that's right. 2, -3, that's where it would be right there. That's going to be where our graph is really going to transition or turn. Then we've got 3, -5 there, and then 10, -7 out here. Okay, so this is our graph. See how well I can do this. Not very well, apparently, okay? Close enough, okay? All right, so that's our graph. So again, when we're talking about cube roots, I love cube roots, y'all, because the domain and range are always going to be all real numbers. There's no restrictions on the domain and range. Now, when we talk about end behavior, okay, so as we move towards the right over here, what's happening to y? Do y'all notice? It's moving towards -infinity. As we move towards the left, what's happening to y? It's moving towards +infinity. Y'all notice that? Okay, so now when we talk about our zeros again, we're going to set that 0 equal to 0. I mean, that equation equal to 0. So we're going to say 0 is equal to negative 2. Again, we've got the cube root of x minus 2 and then minus 3. So I'm going to add 3 to both sides. That's going to give me 3 is here. Negative 2 again, cube root of x minus 2. So what I'm going to do is I'm going to divide both sides by negative 2. It's going to be 3 over negative 2 is equal to the cube root of x minus 2. Okay? So I'm going to extend this page down here so I have a little more room to work. So now aren't we going to cube both sides? We are. So we're going to cube both sides. So that's going to give me 27 over negative 8. And that's going to be equal to x minus 2. So now we're going to add 2 to both sides, right? So this is going to be negative 27 over 8. And we're going to add the 2. So I'm going to make this an improper fraction. So we're going to add to it 16 over 2. And that's going to be x. And again, you guys can do this with a calculator and it will give it to you the answer. So if I got negative 27 and so this is going to end up, sorry, that should have been an 8, y'all. Because that's 2, right? Okay, so then that would be 11, negative 11 over 8, wouldn't it? Okay, so that's equal to x. So that means x is going to be equal to negative 1.375. So that's going to be my 0. X is equal to negative 1.375. So let's look at our graph. It kind of looks like it's about there. Y'all see where that is right there? That's where our x-intercept is right there. Let me do it in red so you guys can see it a little better. Y'all see it right there? That's about what it was, okay? So now, is this graph increasing or decreasing? I don't see it increasing as I move from left to right. So I'm going to write none here. And when's it decreasing? It's decreasing from negative infinity all the way to infinity. Do y'all see that? So we're now talking about our x values. So hopefully this video helped y'all.